Hey everybody, welcome. This is Mr. Beckstrom, and today I want to take a look at doing some conversions from section 5.1. We're going to look at converting from degrees to radians, radians to degrees, and we'll have also some minutes and seconds in here with some of these degrees. So I'm looking at three different examples, and the main tool that we're going to use in here is using unit fractions for converting. So I can use any kind of conversion that I want to, any two quantities that are equal. So I can use the fact that 2 pi was equal to 360 degrees, but my most basic equality there would probably be that pi is equal to 180 degrees. So that's what I'm going to use for my unit fraction there. So I know that pi is equal to 180 degrees. And pi is what I'm going to use for radians, and 180 degrees is what I'm going to use for my degrees. So I can set up two unit fractions for that. I can either set up pi over 180 degrees, or I can set up 180 degrees over pi. So I can use either one of these. Now it depends on what I'm trying to cancel out. If I have my degrees on top and I want to cancel out the degrees, I'm going to use this first one because then the degrees will be on the bottom of this unit fraction and I can cancel them out. If my radians are on top, then I'm going to use this second one because then I can cancel my radians out and get my answer in terms of the degrees. So let's take a look at an example. Let's see. So this first one here is 32 degrees. So I'm going to just put right in there. So I'm going to start with the 32 degrees. I always start with my known quantity. Go ahead and put that over 1, just because I can put anything over 1. And I'm going to multiply that by one of my unit fractions here, and I want to convert this over to radians. So which one of these do I use? Well, I want to get it out of degrees and into radians. So I'm going to want my degrees to be on the bottom. So basically then I'll have a degree on top, I'll have a degree on the bottom. Those degrees will cancel out and it'll just leave me in terms of the radians. So therefore I'm going to pick the first unit fraction here. So I'll have a degree on the top and a degree on the bottom. So that's why I'm picking that first unit fraction there. So times 100 degrees over pi. So since pi is equal to 180 degrees, something divided by itself is just equal to 1. So I'm not really changing the quantity because anything times 1 is just itself, and pi and 180 degrees are equal to each other. So we're really just multiplying this 32 degrees by itself. So therefore, the degrees will cancel out, and I'm just left with 32 pi over 180. And then all I really need to do is just simplify that 32 over 180. And at that point, if you just wanted to find all the factors of 32 and 180, do that you can. I like to use my graphing calculator, which is required for this class. So I'm just going to do 32 divided by 180. Enter. I get some decimal point, and then I'm going to hit math, fraction, and it tells me that 8 over 45 is in lowest terms, so my final answer would be 8 pi over 45. So 8 pi over 45, and that's how we get the lowest term. That tells us that I can divide both the top and the bottom by 5, and that would be the largest positive integer that I can divide the top and the bottom by. So that would be my answer. So 32 degrees is equivalent to 8 pi over 45 radians. Just put radians here. and this would be in terms of radians. So if they told you to leave the answer in terms of pi, this is what it would be. Now, if they told you to not leave it in terms of pi, they wanted the exact answer, then you would take this answer right here and you would multiply it by pi. So you would say times, if you did not have a pi key, you could approximate it to 3.14, but you could just do that and it would be approximately 0.5585 radians. All right. So the next one is they're going to start with radians here. So we're going to start with pi over 7. Pi over 7. Excuse my ugly pi. Let me fix that pi up a little bit for you. So we're going to start with pi, and we're going to multiply. So notice we started with the pi on the top. I want to get rid of my radians. So I want to get this pi on the bottom there so we can get out of those radians. So I'm going to use this second unit fraction now. So using that second unit fraction, that'll give me a pi on the bottom. I have 180 degrees on the top. And that pi will cancel out with that, just like I should probably get it canceled out, those two from earlier. And now I am just left with 180 divided by degrees divided by 7. And I don't think 180 is divided, or 7 divides into 180. Let's just double check. 180 divided by 7. It does not. If I do math, that's what it is. So this one would just be left just like that. 180 divided by 7. Or you could divide that in and leave that as a mixed number if you wanted to. And you could probably do math and convert that to a mixed number. I forgot how you do that, but I'm sure you can figure that out. All right, but this is how my math lab is going to take that. Usually they want the answer in a improper fraction form like this. Okay, and this last one here. So we rarely see anything that we do. In fact, I think we're only going to see these minutes and seconds in this one section, maybe 2 sections. Beyond this, we're only going to really just see it in these 2 forms here. But I need to show you this. So this means 36 degrees, 15 minutes means that this is 15 over 60 degrees. And this 13 seconds means that's 13 over 60 minutes. 13 over 60 minutes. So it's kind of overly confusing, but we can rewrite this whole thing like this. We can say this is 36 degrees plus, we said this is 15 minutes is just 15 over 60 degrees, right? Because that's the minutes. And then plus 13. Now remember, this is 13 over 60 minutes. So in order to convert that to degrees, you'd have to multiply there's 60 minutes in a degree, and there's 60 seconds in a minute. So 60 times 60 is 3,600. So 3,600 like this. Then you can convert that to degrees as well. So this would actually convert to a single decimal degree. So if I put that in my calculator, that would be, so 36 plus 15 divided by 60 plus 13 divided by 60 times 60, which is 3600. Enter, and you're going to get 36.25, this long decimal here. And then in order to convert that to radians, so I'm going to put this on my other screen here. We'll go ahead and go out like 4 decimal places here. So this right here is really 36.2536 degrees approximately times, my mouse is not agreeing with me very well here, times, now remember this is degrees, so we need the one with degrees on the bottom, so times pi over 180. Now this is not a nice fraction here, so really all I'm going to do is just take this value here and divide that by 180, so divided by 180, and you're going to get this decimal here. So it'll be this decimal times your pi there. So 0.2014 pi. So this is approximately equal to 0.2014 pi. And we use these little approximate equality symbols here to show that this is not exact. So this is how we convert over here, because there's 15 minutes in a degree and there's 15 seconds in a minute. So we can kind of convert it like that. This converts it into a decimal form of the degrees, and then we just use the conversion before and convert that into radians. And then if you wanted to convert it to an exact radian, then you just multiply it through by pi. But we're going to have to use some approximations along the way. And if we were doing this in my math lab, then you would want to, at the second step here, you would want to go pretty far out. You might even want to go 5 or 6 decimal places, and then you'd want to round to whatever place they said at the end. So if they said 3 decimal places, round to this place here, and 4 would be there. All right, I hope this was helpful. If you have any questions, please let me know, and I hope you have a great rest of your week. Thank you.